Hello everyone, this is Sky speaking. In this section, I will talk about the execution order of Verilog language. We have talked it before. When we are writing some simple Verilog code for the basic logic gates such as AND, OR, and DFF, at that part, we try to understand the execution order of Verilog language from the view of hardware, that is the behavior of real silicon, or you can say the behavior of real digital logic gates. And we say the nature of Verilog language is event-triggered and parallel language that is used to will match the behavior of real logic gates. But actually, Verilog language is a programming language. After it was compiled, it will be executed on the CPU core. So, what's the execution order from the view of software? In this section, I will explain the execution order from the view of software. Verilog language has defined some rules for the execution order on software, or you can say on CPU. First, the statement will be scheduled to different times, that is the simulation times. Statements scheduled at early time must be executed first. Let's say an example. What is schedule each statement? For example, this statement will be scheduled after the power up, that is after the 0th nanosecond of simulation. Then wait for the linkage of reset. So this statement will be scheduled at the first linkage reset after the simulation is run up. For this statement, it will be scheduled after the passage of reset. So this is how to schedule the execution time of each statement. For example, this statement will be scheduled at the positive clock. At every positive clock, a linkage reset. Yes. Okay. So for statement scheduled to different simulation time, they are executed in the order of simulation time. Then, how about the statements scheduled to the same time? For example, okay, this statement and this statement, yes, will be scheduled to the same simulation time. Yes, they are all the first linkage reset. And also, this statement and this statement will be scheduled to the same simulation time. What's the order between them? Okay, the rule is, if you're using the non-blocking assignment, or the non-blocking assignment scheduled to the same simulation time seems they are executed at the same time. Yes, they are executed at the same time. But for blocking assignment, if they are in the same coding block, that is in the same always block or in the same initial block, they will be executed in order. In the order they are in the code itself. That is, if these lines are scheduled to the same time, Yeah, they must be scheduled to the same time, and this line will execute first, then this line, then this line. They are in the order. These code are written in the RTL code. But for statements in different code blocks, Verilog language undefined the execution order. Yeah, any order is allowed. So for example, you can answer the question now. The execution of these two lines and the execution of these two lines, the order is undefined. Yeah, the order is undefined by Verilog language. So each simulation tool can have their own orders. So if you write some code like that, you may get different behavior for different simulation tools. For example, after that, what's the value for this signal? Yeah, after the first linkage of reset n, what's the value for this signal? Is 0 or 1? Not defined. Okay. Different simulation tools may have different behavior. So, important notes. You have to avoid writing code like this. This is bad coding. This will confuse the simulation tool and confuse the reader. It's hard to maintain. Okay, you should avoid coding something like that. Okay, this is a rule. When Verilog code is compiled and run off in your PC, or you can say in your CPU core, this is the order. This is the order from the view of software. So let's say some examples. Let's first look at the non-blocking assignment. That is, we are usually use the non-blocking assignment to model the behavior of register, or you can say the DFF. Yeah. So take a look at the two code segment. Okay. Where the function of them is almost the same, a lot. This is rig 0, rig 1, rig 2, and this is also rig 0, rig 1, rig 2, but the order in this part is different. Yeah, the coding order. This order we first assign value to 0, then rig 2 and last. But this part they are inversed. Rig 2 first and rig 0 and last. So do you think the function of the two is almost the same, or they will be different? Okay. As I have said, the rule for non-blocking assignment is always three statements will be executed at the same time. So at the rising edge of clock, at the rising edge of clock, it will use the value of this input, or you can say of this right hand side, the value just before the rising edge of clock, just before. Okay, you can say nearly a infinite small number of delta. Yeah, a very small positive number of delta. We just use the value of these signals at that time and update it to the left hand at the right edge of clock at the same time. So rig 0 will get the value of A0 at this point, and rig 1 will get the value of rig 0 at this point. That is the old value just before the rising edge of clock. Also, rig 2 will get the old value of rig 1 just before the rising edge of clock. Okay. So even this line is written after this line. The value used here, the rig 1 value used here is the old value, okay, before the clocking edge, not the newly updated value after the clock. And also, this is true for this statement. Okay, they all use these values, the old values just before the rising edge of clock to update the left hand side. So you can see the waveform. The waveform is the same for the two coding. So they are all shift registers. Okay. Let's see the order of blocking assignment. Okay, we use blocking assignment in this always block. As we have said before, for blocking assignment, the order of the statement is the same as the order they are written in the code. So the execution of this statement will be in this order. Yeah, they first executed this and updated the left hand signal, then execute this line and update the left hand signal, then execute this line and update this signal. So from the waveform you can see at the right edge of clock, all these three signals will get the new value. Yeah, all these three signals will get the new value. As when executing this line, the value has been updated. So can you understand the waveform for these three lines? Yeah. Where the function of the three lines behavior is the same as shift register. Can you understand it? For example, at this edge, and this trigger, this line will be executed first. So the old value, yes, the old value of this variable will be assigned to here. Then this value will be updated to rig 0. At last, rig 0 will be updated. So they behave like the shift register. So at this point, you can understand why we have said that if you want to coding register, you have to use the non-blocking assignment. Yeah, you have to use the non-blocking assignment. Why? Because the behavior of the non-blocking assignment has no relationship with the coding order. Yes? But for blocking assignment, it's tricky. Yes, it's tricky. The behavior relies on the coding order. Okay. So please make sure if you want to describe sequential logic using non-blocking assignment. Okay. And don't be worried. The link tool, if you make some mistake, the link tool will report you some error or warning. At that point, just fix it. So the behavior of blocking an assignment, if you are using it to describe sequential logic, the behavior is rather tricky. Very tricky. It depends on the coding order. So at the debug stage, if you modify some code and change the coding order, they will behave totally different. That's too tricky. Okay. How about the order of blocking assignment in different code blocks? As I have explained, they are undefined. So we don't know this display or this display who will print first and who will print after that. I don't know, and we don't know the value for this signal is 1 or 0 after the execution of the tool. We don't know. Okay, it will depend on the simulation tools. So when you writing test bench, you have to avoid writing code like that. This is confused. You can write some sample code to test this statement I said before. To verify it, the statement made by me is wrong or right. Yeah, you need to have the ability to justify them. Yeah, just write some sample code. Okay, that's all for this section. Thank you.